Okay, we're on worked example 7.8, and as you can see, I tried to straighten the video out for you a little bit. So, use the binomial theorem to expand and simplify that expression. This is actually a simpler one than the previous one. The strategy we're going to take here is we're going to expand this. Use a different color besides black. We're going to, no, I don't want to use that color either. Sorry. We're going to expand this first using the binomial theorem. And then we're going to use the grid or FOIL or however you do to then expand this onto the result of number 1, if that makes any sense. So this is first, and this is going to be second. Okay, so let's expand this thing first. It's pretty simple. Right now, that should be very simple. Your A is equal to 2. Your B term is negative x. Your N is 4. And the R is going to be different things. So let's go ahead and do that. So it's going to be, I like to do straight down the left-hand column. It's going to be 7, 0 for your first term. Your second term is going to be 7, 1. Your third term is going to be, oh, it's not 7, is it? That's 4. Thank goodness. I was like, what? It's going to be the wrong problem. 4, 4, 4, 2. Your next term is going to be 4, 3. And when we get to 4, 4, we're done. When you have the same number repeated twice, that means your last term. So, and which makes sense, if you have to the 4th power, you're going to have 5 terms. So, we know we have all our terms. That's your binomial coefficient. Now we have to do our A term. So 2, 2, write my times, 2, 2. And it's N minus R, so it's 4 minus 0, 4 minus 1, 4 minus 2, 4 minus 3. And I forgot one. There we go. And then for your B term, you're going to do negative x. Make sure you put in parentheses to the R power, that's 0. Make sure you're putting it to the R. The R is the bottom number in the binomial coefficient. And that's all we need. Simplify straight across. Now this is the 4th row of Pascal's triangle. I'm going to try to look that up. Why am I looking that up? I remember seeing it in my Dropbox or somewhere. I'm just going to look it up because I'm feeling lazy. Like typing in my calculator. So Pascal's triangle, you probably put that in front of the camera. Okay, it's not going to focus. Maybe I can help it focus. There you go. As you can see, row 4, you can barely see it. Row 4 is 1, 6, 4, 1. That's row 4. 1, 6, 4, 1. There you go. So, back on that. So it's 1, 6, 4, 1. So that's your binomial coefficient. 1, 4, 6, 4, 1. That's this part right here. Times 2, this is 2 to the 4th power, which is 16. And this is 2 to the 3rd power, which is 8. This is 2 squared, which is 4. This is 2 to the 1st power. And 2 to the 0 power is just 1. Okay, anything to the 0 power is 1, so that's 1. This is negative x. This is x squared. Somebody's calling my number. This is negative x to the third. And raised to an even power, it's going to be positive, so it's x to the fourth. Okay, so we have... Now I'm going to go ahead and write the second part, so 5 minus 3x. And it's times all of those terms, so let me simplify it. 16. So the first term is 16. Second term is negative 32x. The next term is 24x squared. And then negative 8x to the third power. And then just x to the fourth. You're going to separate all those terms by plus and minus signs. If they're positive, a plus sign. If it's negative, a minus sign. And now you're going to use FOIL or the grid to expand this. I know it seems like a lot of work, but really this is the only way to do this problem. So it could be worse, I guess. Okie dokie, I'm not looking forward to it either. I'm going to kind of use FOIL because the grid gets to be kind of annoying. So it's this times all of these. And then this one times each of these. So let's see. 5 times 16, 80. Try to write small. Try keyword. 80 minus 5 times 32. 160 x plus 24 times 5. 120 x squared minus 40 x to the third plus 5x to the fourth power. And then when I do this negative 3 times everything, I get more. It's going to be negative 48x. 32 times 3. I could figure that out, but I don't feel like it. It's going to be a positive 96x squared. We're going to know your algebra. 24 times 3 minus 72 x to the third power plus 24 x to the fourth power minus 3x to the fifth power. Now we have to combine like terms. We're still not done. But we're almost there. We just have to combine like terms. So let's see. I'll try to write really small on the next line. Equals 80 is all by himself, I think. 80, and then how many x terms do we have? We have 2 of those. Negative 160 and 48. Negative 208. Minus 208x. And then x squared, we have 120 and 96. The third, we have negative 40 and negative 72. Negative 112. X to the fourth power, we have this one and this one. At least I can add those in my head. And then we just did 1x to the fifth. And that should be the final answer. So rarely on the exam do you have to expand the whole thing like this. Usually it's like the other example where you had to find just one specific term. So, because as you can see, that would take a lot of time on the exam. But anyway, it's kind of tedious and annoying, but you may have to do this. But it's nothing you can't handle. It's just tedious and annoying, and one little careless error will throw off the whole thing. So anyway, you are going to work on the exercise. Let me go grab my, I don't have my book, but I'm going to grab my computer and look up the exercises and tell you which ones I want you to do based on these examples. Let's see. I had it pulled up on my computer. Should have left it up, but no. Let's see, it's add a page. Let's see, what I want you all to do. 7C. You can do covers a lot. Okay, let me look at the first two examples. So you can do numbers I'm looking. See which ones match the ones. You can always look in the notes if you want to watch the rest of this. I'm going to send you all the notes. A lot of these were from Friday. You can do number 9. That's like the first example. You can do number 11. Twelve, 13. They're all blue. Some of them start to get a little weird. From 14 on, it gets a little weird. But number 18 is just like the example that we did, the first example. That's just like the example that we did. So you should be able to handle that. If you just want to practice what you learned in that example just from that one problem, that would be fine. And not that the rest aren't doable, it's just that they are, but they get to be kind of long. So I don't know how much energy and time you have to invest in those, but they get a little bit weird and a little difficult. If you did not already complete numbers, I probably on Friday, it's not Friday yet, this is Wednesday I'm doing this, but probably going to assign on Friday with numbers 1 through 8 or something like that. So if you have not already done numbers 1 through 8, then you should work on those. Number 10 you can't really do until we do that last example. So you're going to skip that for now. Um, 13, 13's on that list. It's a little weird. I mean, I can do these, but for y'all, they may be a little weird. So, but I do want you to attempt them if you have time. If you don't have time, it's not the worst thing in the world. Some of these are way more difficult than what's actually going to be on your exam. Some of these kind of stem more into higher level type questions. So, you know, they're good practice, but I don't want you to feel too overwhelmed. So anyway, if you can just do like numbers 1 through 9, and then 11, 12, and 13, and probably even 18, then you're probably good. So let's do Wednesday, I think, because I don't think I have y'all on Tuesday, if I remember correctly. So, all right, that's it for the lesson for today. So go ahead and work on that, and I will see you in the next class period. I think that's Wednesday.